Welcome back to the channel. In today's video, we are going to explore the very first stage of data engineering lifecycle, data generation. Data generation is where everything begins. It refers to the creation of raw data, which is basically unorganized, contextless facts and figures. This data can come from countless places and it may be messy, incomplete, or unstructured. Most importantly, data can be created in two ways, analog and digital. And understanding how data is generated forms the foundation for all the downstream engineering tasks. Now, moving on. Broadly, data organizes in two forms, analog and digital. Analog data is created in the real world, for example, your voice, physical temperature, etc. Digital data, on the other hand, is produced by converting analog data into digital form, like audio recordings, or it's natively created by digital systems. Think of your mobile apps, social media clips, or online transactions. Digital data is what powers most modern data pipelines. Now, let's look at the main sources from which data is generated. The first is files. They can be structured like CSV and Excel, semi-structured like JSON or XML, or completely unstructured like text logs. Next, APIs. These are standardized interfaces that help different systems exchange data. APIs simplify the ingestion process for data engineers. Then we have OLTP databases, which supports fast reads and writes for applications. These handle thousands of small transactions every second. And finally, OLAP systems, which are designed for heavy analytical queries instead of simple lookups. They are backbone for large-scale analytics. Okay, now, when we talk about databases, we must understand ACID properties, a key concept in ensuring reliability. ACID is atomicity, consistency, isolation, and durability. Atomicity means a transaction happens fully or not at all. Consistency ensures that every read and returns the most recent committed data. Isolation ensures that even if users update the database at the same time, the final result is consistent. And durability, it guarantees that once data is written, it stays written even if the system crashes. Okay, next, moving on. Another extremely important step is data logs. Logs record events that happen inside systems like user logins, server errors, or API calls. They are incredibly valuable for analytics, machine learning, debugging, and automation. In fact, modern monitoring and alerting systems depend heavily on log data. Next, we have CRUD, which stands for create, read, update, and delete. These are the four basic operations performed on data in databases and API. Every app you use, from Instagram to banking apps, performs CRUD operations constantly. Understanding CRUD is essential for anyone working with data. When working with source system, security is non-negotiable. We must encrypt data both at rest and in transit. We secure VPNs and store passwords or API keys safely. Data management is equally important. Understanding who owns the data, maintaining quality, preparing for schema changes, and following privacy and regulatory rules. Good data engineering is not just about collecting data, but collecting it responsibly. Next, data ops focuses on monitoring, communication, automation, and recovery planning. Data engineers need to stay aligned with data ops teams to ensure systems are running smoothly. At the same time, understanding the architecture of the source systems, their reliability, recovery speed, and SLAs is crucial. All of this ensures that data pipelines don't break unexpectedly. Orchestration and software engineering. And finally, orchestration and software engineering practices tie everything together. We need to ensure the right network access, authentication, and authorization to reach source systems. We must also handle retrace, timeout, scaling, and deployment using proper engineering principles. This ensures that data flows constantly and reliably from source to destination, the ultimate goal of data engineering. So that's a complete overview of data generation, the first step in the data engineering life cycle. So you can find the notes for this video in the description. And thank you everyone for watching this video. And please like, share, subscribe, and do come back for more amazing content.